So this week we are going to talk about asynchronous programming. So I will start the first session and Samira will continue on promises. And the first thing is this question, like you may heard that JavaScript is single threaded and it's concurrent language. Like I think most of us are not aware of this, and like somebody asks, what do you mean by that? Like you will get stuck, right? So I think I'll start by addressing what's the thread and then talk about the concurrent behavior of JavaScript. So how it would work uh, in this situation. So first of all, I'll go from saying what is a thread. So this is not like specific to JavaScript. This is like for anything, any not anything, any programming language. Let's just say you have some code right here. So you have written some code in some language. So it's basically English, right? But in order to computer to understand this, the CPU only understands like bytes, ones and zeros. So we need to convert this to line by line to this binary code. So this is just take this as a first step. Like I'm telling you a very high level of things how this is gonna happen. I'm not going to like explain like each piece how is this gonna happen. Just think of it as this: you have written code in English, and you are going to convert it to binary code. So in order to computer run your code, this binary code is stored in the computer's RAM. So these ones and zeros, these bits are inside your computer's memory. Okay, so this is like ugly drawing that I created. Just imagine this is your RAM, and inside this RAM you have this binary code. This binary code, these are in hex format for easy to understand. Just imagine these are binary, your instructions of your code. So you have this 8F, 2C, CA, 6A, 3C. So this should be passed into the CPU. Just imagine there's a CPU right here. So you are feeding this information of your program. You have to pass it to the CPU in order to process. So what happens is RAM's gonna pass these instructions to the CPU, and there's a queue in the CPU. So it will add. So first one goes 8F, 8F goes here, 2C goes, 6A goes, 3C goes. Like this unit of execution, like this is called a thread. You are passing data to RAM to CPU. This kind of unit of execution is a thread. So there's a problem with single thread programming, as you can see. Like if 3C want to be executed, you have to wait. 3C has to wait until this tree getting completed, right? So you might think single thread programming is slow because in 3C has to wait for some time. But in actually, this does not happen like this, because if you apply this concept, this single thread concept to JavaScript, as you know, JavaScript doesn't like provide you like blocking behavior. Like it just runs code top to bottom. So how does JavaScript do that? It applies a concept called concurrency. So with JavaScript adapts this to principles, single thread, and it combines this concurrency. So JavaScript doesn't get slowed down. You might think single thread is slow, but with concurrency, JavaScript gets powerful. So let's say what is concurrency. So let's imagine the same RAM. I have color coded the task. you have blue task, orange, red, and green task. Then let's say these tasks are now going to CPU. So a blue one goes, orange one goes, and red one goes. So as for a single threaded program, so these it should execute one by one, right? But let's say this blue one is a math function, and let's say this orange one is a printing function. So this instruction said print 100 pages from printer. And let's imagine these two are also some math functions. So there's no need for these two tasks to wait until 100 pages getting printed, right? For your computer, just because you said print something to a computer, your computer doesn't start freezing, right? So what happens is, even though these are instructions are going in a single thread way, this the instruction can be passed over to other hardware or software. So what happens is, you go with the simple task, math task is done, and you get the printing task. That takes some time. So computer is gonna just offload to it to the printing task, and it will take the other task and it continue on. So it will not block the thread just because it received some very time consuming task. So this is basically what happens inside JavaScript engine also. So when we have some task done by asynchronous way, it's a API call or something, the JavaScript thread doesn't wait for until that API calls getting a response. It just getting offloaded and it takes the next task. I will explain this with the engine architecture also. So in here, when we are running code in the browser, so there are few things browser considered as asynchronous. So API calls, set timeout, set interval methods, input output operations like clicking, inputting something with keyboard, and you can create your own async tasks. These kind of things are called like time consuming tasks, right? When API call getting added to the thread, uh, it's not suitable for like blocking the thread just because there's API call waiting a response. So let me show you with that example with the JavaScript engine. So even though JavaScript is a single threaded environment, that this has some additional features in the browser. So we have JavaScript engine here, it's single threaded, but it provided with additional browser software. Browser has web APIs and a callback queue and event loop. I will tell you what these are in the future. So if you take about JavaScript runtime, you can see there's a heap and there's a stack. So the basic need for heap is keeping your variables memory locations. So if you add some variables, so it's add to the heap. That's where your variable names and values are stored. And the stack is for running your functions. So let's say you have a code and you have these three functions. This will push into the stack like foo, babas. So this will be added to the stack and it will start executing in this stack. Then now this is all right. Just imagine only this part, this JS cycle part, and don't think there's event loop and these web APIs. So let's think this bus is a API call. So if there's no web APIs provided and there's no additional features provided to this JavaScript engine, what's gonna happen is this stack gonna freeze, right, until the API call is getting a response because this program is not getting completed. So without this additional software, the JavaScript will like become very slow. But this problem is solved by web APIs and other additional features added to the browser. So what happened is, let's imagine this bus is a asynchronous call. It's like any of these things. So what happens is when it gets to the stack, JavaScript will just offload it to the web API, and web API will take care of what's happening here, just like I talk about concurrency. So this is the concurrency principle happening here. So what it does is it just offloads its time-consuming task, asynchronous task to the web API, and web API will run it in their own time, and it will be added to the callback queue when it's done. Let's say you have sent a get call to get some data. So then this program is running, and also get programming that call is also done, and you receive the data for the get call, and there's a callback function inside your API call, and that callback function will add to the this callback queue. And the event loop is here between stack and the callback loop. Sorry, callback queue. You can see the event loop is right here turning. So event loops only job is to put this callback queues functions back into the stack to execute. So what happens is you provide the asynchronous call here, asynchronous calls runs, and it provides the callback functions to the callback queue. Then event loop comes in and say check if here we have some functions to add to this stack, and it gets added to this stack. Then it runs. So event loop will only add functions to the stack. Only the stack is empty. If there's three functions, like in this example here, there's three functions and there's two functions here, but there's three functions here, so it's not empty. So event loop not gonna add this only can onload to the stack. It will wait until these three functions run, and after this is empty, it will add this asynchronous calls to the stack, and the stack will execute them again, and it will be over. Execution cycle will be over. So I will show you this by some example. So this is a website that shows you that web API thing, how it's happening. So I will start by a code example. You guys can see my other screens, right? Also, like code, VS Code.
Yes, yes.
All right. So let me take this code piece of code and let me explain what's here. This is a simple functions I have created. Function 1 is a synchronous function. Function 2 has a set timeout code. So this is the asynchronous code. And 3 is again synchronous function. Let's see how this happens in the browser. So I'm gonna run it. So first, function 1 is added to the stack and it runs. It's a synchronous function, it's fine. So now this occurs asynchronous function. So this will be added to the web API to run. See that? See now the web API is take caring of that set timeout call, and when it's done, it will be added to the callback queue. And see right here, there was set timeout to added here, but it was not added immediately to the call stack. It waited in the callback queue, and the third function was taken. That's because I told you earlier, the callback queue only takes this event loop only takes this callback queues function if there are no any other functions in this stack. So now the third function is executed, it's done. Now what happens is now timeout function, we can get the timeout function and it runs in the call stack. So this is what happens.
Yeah, it was me. I had a question. Can I ask?
Yeah, let's try.
No, I just wanted to see in the web API you are adding that, no, not you, that set timeout is added to the web API, right?
Yeah.
So it takes 1 second. I saw that after it is coming, it came to the callback queue only, the third function ran. function 3.
Yes.
Is that how it
Uh,
works? Like it takes 1 second means until that it's already run that function 3, right?
no, there's, I think I have set the delay for here, but basically what should happen is like this is happening like really fast. Like function 1 goes here, it get executed. 2 is asynchronous post, it get added to the web API and it comes to the callback queue.
Right.
Then the third function is added to the call stack. It like this is happening fast. Like you may see like a delay because I have set a delay. But this program, this is
Right.
the stack is the like priority. So this function is
Yeah.
getting added here.
So that 1 second is spent on the web API, right? Not on the callback queue. After the 1 second only, it will come to the callback queue, right?
Yes, yes. It will run in the web API and it will take care of the time consuming functions, and it once its time is completed, it will add it to the callback queue.
Right. Thank you. Yeah.
All right. Okay. I have another example. Let's say we have 4 asynchronous code. These are all now the code is fully asynchronous. Let's see what happens here. So first timeout is added. As you can see now, until all the functions are executed, these callback queues functions are not added to this stack. But there's a drawback for this. So basically, you might think if you set timeout for 1 second, it should always execute after 1 second. But in this case, this function would not run after exactly 1 second, right? So 1 second has passed, but it still didn't no console logs. Callback size is still in the queue, and now runs everything after the async functions are completed. So this is what happens in a single thread programming. So like if all the code is asynchronous, this doesn't guarantee you that 1 second after 1 second has passed, this will console log, because we are not doing any of this parallelly. If this runs in parallel, there will be 4 console logs at the same time. But in here, it doesn't run like that. So remember this, when we're using set timer code, this 1 second doesn't mean like this guaranteed 1 second. Like it's the minimum amount of execution of time what is going to execute. It doesn't mean like this will run just after 1 second has passed. So this is another thing I have to say. All right. I think this is what my part was. Yes. Now I'll pass the screen to Chamira.
So I'll be talking about promises and async await. For promises, I'll be covering what is meant by promises and how to create the promises, promise chaining, and promise API. So what is a promise? A promise is simply an object in JavaScript, and it has 2 internal properties. It has the state and the result. State of the promise has 3 statuses. One is pending. It is the initial state. It is neither fulfilled nor rejected at this point. The next one is fulfilled. This is the state the task completed successfully. The other state is rejected. The state when the task is failed. So what does promises in JS mean simply? I'll tell you in a small scenario. Imagine a scenario where a specific medicine is not available in the hospital, and the doctor writes the prescription to the patient's guardian to go purchase from an outside pharmacy. The guardian calls up a close friend who lives nearby to search for the medicine. He says, "If you find a place where the drug is available, can you promise you will call so I don't have to travel searching for the medicine. He also added, if you didn't find the medicine, inform me, so I will immediately go and search in another area. His friend then says, I promise I'll inform you. So now the doctor's drug requirement request is pending until the drug is found. As the patient's guardian was waiting in the hospital, he got a text from his friend saying that he found the medicine and he's on the way to the hospital. Therefore, the doctor's drug requirement request is fulfilled and the doctor can treat the patient. If the text message said the drug is not found, then the guardian must leave the patient behind and try searching for the drug in another area. So how do we put this scenario in promise JS? So according to the scenario, the friend is the promise, and the friend promising to get the medicine or finding the medicine is the asynchronous operation. And whether the friend can get the medicine or friend cannot get the medicine is the promise return value. If he's able to get the medicine, then his promise is fulfilled. If he is unable to get the medicine, his promise is rejected. So based on these two results, we have to carry out the operation next. So if the promise is fulfilled or the friend can get the medicine, a success callback function should be executed. So in the scenario, the doctor can treat the patient. If the the friend is unable to get the medicine, the guardian has to go to another town to search the medicine. That is a failure callback. So we have how to create a promises in JavaScript. So there are three stages to create a promise. First is creating a promise, and then rejecting or fulfilling a promise based on the return result, and then executing functions based on reject or fulfill. So in JS, we can create a promise following this syntax. We can create an instance of promise using new keyword with the promise constructor function. So after we create a promise, how do we fulfill or reject a promise? The promise constructor accepts one function as an argument, and that function receives two arguments called resolve or reject. And they are also functions and are predefined by the JavaScript engine, so we don't need to create them. They are used to resolve or reject the promise. Promise state cannot be mutated. Therefore, to change the state of a promise, need to call resolve or reject functions. These functions are called after an asynchronous operation. So according to the scenario I told you, if the friend is able to find the medicine, we have to resolve it. Let's see. Let's imagine the friend takes 10 milliseconds to find the medicine. So after 10 milliseconds, if the friend is able to find the medicine, we can resolve it, saying that he was able to keep his promise and get the medicine. If he's unable to get the medicine after the duration, then we have to reject the promise. So next we have to talk about if either the promise is resolved or rejected, how to act on it. So to act on it, there are consumers that used to carry out operation based on promise return values. There are three consumers, then catch and finally. Then is a function that runs when receives the result. It receives two functions as arguments. First run when the promise is resolved. Second runs when the promise is rejected. The catch consumer is a function that runs when it receives the error. It receives the function as an argument and runs when promise is rejected. Finally, It acts like the try-catch finally closes. It is a cleanup function in promises that runs after promises settle, whether it's rejected or resolved. This clause allows to perform cleanup or finalize after previous tasks are complete. We can use finally in situations like until the promise is returns a value, we put loading action. So in finally clause, we can put like stop loading when like until it will wait until, and then after it receives the result. In the finally clause, we can put to stop the loading action. So let's see these consumers in code. Okay, so first I'll go through. So here I have created a promise, and it is first resolved. So after we, if it's resolved, an addition like action should be followed according to the result. So there are two operations. If the result is a successful one, this function should be executed. If it's a failure, this one should be executed. So as is about the then consumer, it has two arguments. So it will get the fulfillment and the on failure. So if the promise is resolved, as you can see in the console, it's logged. Promise will return a successful result, and then the fulfillment function is executed. Therefore, it logs friend found the medicine. The doctor can treat the patient. In case if the friend is unable to find the medicine, we can reject the promise. Now we can see then the result is a failure. So this function, second function, is executed. So we can see in the console it's logged. Friend did not find the medicine. The guardian has to search the medicine in another town. So we can write this in a cleaner way. We can use then clause to only handle the success code, and catch clause to handle the failure. So it works in the same manner. So if it's resolved, this function on fulfillment is executed, and it will log the result to the console. And then after since we have attached the finally clause, it will say we received the result. Next is promise chaining. Both then and catch method return promises, and they both can be chained in JS. Chaining can be done as many times as you want, which enables to handle codes that result in callback hell in a cleaner manner. So this is an example for a callback hell. So this is difficult to read, understand, and maintain. So using promise chaining, we can write in a cleaner manner, and we can maintain easily. Next, let's talk about promise API. There are four. These are four promise APIs: promise.all, promise.settleAll, promise.raise, promise.any. So promise.all is a method that takes iterable of promises as an input and returns single promise. The promise resolves when all listed promises are resolved, and the array of the results become the result. Return promises will resolve when all the input promises have resolved, if the input iterable contains no promises. If any of the input promises reject or non-promises throw an error, the promise reject immediately. Let's see it in action. So here I have written a few statements, and this is the code for promise.all. It receives 3 promises. The intervals are passed to promise.all, and we can see the result is logged here. It's what all the promises have resolved, so it will output these values in the console. So as according to the all the promises should be resolved. If either of them is rejected, then it will throw an error. For example, let's see, reject. So it shows an error. So all the promises should be resolved in this case. Next is promise.settle all. This promise settle all awaits for the input promise to complete, whether any of the promises is rejected or not. Promise.settle all returns all promises even though it has a promise that is being rejected. So in this case, all the promises have been successfully completed. Let's see if either of these promise is rejected. So you can see that this didn't throw an error, but it actually executed all the promises and displayed here. So it will display as rejected and the reason. So unlike the all, this will execute all the promises, even though one of them has failed. The next one is promise.raise. Promise.raise is similar to promise.all, but waits only for the first settled promise and gets its result. This means even though it looks like a promise.all, promise.raise won't wait till all the promises are completed. As soon as one of the promises get completed, its result is returned. So you can see that it doesn't wait until all the promises are resolved or rejected. Even though reject is there's a rejection, it will run, but it will consider like the fastest executing promise, and will return the result. See if it's reject. So it doesn't matter if it's reject or resolve. It will consider only the fastest promise to be returning the value. Next one is promise.any. Similar to promise.raise, but waits only for the first fulfilled promise and gets its result. If all the promises are rejected, then the return promise is rejected with aggregate error, a special error that stores all promise errors in errors property. So, let's see. In here, in earlier case, it didn't matter if it was the reject or the resolve. But in here, the status matters. So even though the error is the fastest to execute, it will not taken into account. It will taken into account the fastest and the resolved one. So it will only return the output, return the result for this promise. That's all for the promise API. Next is async await. In here, I will only talk a small content about async await. Here I'll tell what are the async and await keywords and promise chaining versus async await. So async keyword is used to declare asynchronous functions. Async functions are instances of async function constructor. Async functions always return a promise. So you can see in the syntax. For example, after I put print the value to the console, it will log a promise. It will have a state and it will have a value. So if you don't return a promise, the async function will wrap the value in a resolved promise. That is what happened here. So either you can return it without a promise, or you can attach the promise.resolve to the async function. It will display the same value. The next one is await keyword. Await keyword can be put in front of any asynchronous promise-based function to pause your code until that promise is settled and returns its result. Await only works inside async functions, cannot use in normal functions. So this is the syntax for async await keywords. And so in here, result is not logged until this promise returns the value. Next is chaining promises versus async await. So promise chaining is better than callback help, but it can be more readable in async await format. This is async await requires more code, but it looks more readable and maintainable. That's all from my end.
Thank you, Shamira and Dinura, for the wonderful session. So, guys, this will be the end of our first round of the tech talk. And today, unfortunately, we don't have a quiz because Lairu is not available today. So once he is available, we will share you a link for the quiz. Chamik, anything else to add?
No, sorry, I was on a client call, so I was unable to join at time at 3:30. So, thank you very much, Dimran, Shamir, and other guys, doing this tech talk. As Shibli said, this will be our last tech talk session for this year. So we will be sharing the quiz link after Lahir is available. So thank you very much, guys.
Thank you, Chamik. So thank you again, guys, for supporting us for the first round, and we will have a discussion about the suggestions and all what we have, and we can start the second round. So thank you, guys. So see you on the next session. Have a nice day.